Hi everyone, welcome to another video on case study in Power BI. In this video, we're again going to revisit our previous problem, which is to generate hour intervals out of a date time data. However, this time we are going to do it different in that we are going to fully use only DAX to solve this problem. Now, here we have the data set that is similar to previous videos, where we have two columns, the first one being the date time, while the second column being our status. For our date time column, we have multiple different dates. Most of them are within the same day. However, we do have a case where it transitions from the 21st of September to the 22nd of September. Now, keep in mind, the first row of the data would be the start time, followed by the second row, which is the stop time for the first row. So it will start and stop, the start time, stop time, start time, stop time. Or rather, the time intervals. Let me just show you what is the final table that we would like. Now, keep in mind, the question that I'm trying to answer in this problem is, what is the running time for each hour shown on the table? Not each row, but each hour, being the 10 p.m., 11 p.m., 7 p.m., so on and so forth. I've done a trial file here where we see that not only do I have an hour interval column now, I can also calculate the running time for each of the hour interval, being 10 p.m. with a 2.18 minute running time, 11 p.m. 59.47 minute, and then 60 minutes for all of the other hours, while ending over at 7 p.m. at 55 minutes. Let's just cross-check if 12 p.m. on the 22nd of September is indeed running for the full hour. In my original dataset, I do not actually have 12 p.m. appearing on my table because it exists within the intervals between the 21st of September, 11 p.m. 32 seconds to 22nd of September, 7 p.m. 55 minutes 33 seconds. Now, let's see how we can convert this table into this table with the hour intervals while also answering our question. How many minutes is the running minute for the machine, in this case a machine, for each hour interval? Okay. Now, I will first go into my Power Query and change the name of my column so that it's easier for us to refer later. The first thing that I will do is to add an index column. This would be used for reference for the DAX formula later. This is the only step that we'll be doing inside Power Query. And after closing and loading, let's begin our first DAX formula. The first DAX formula is going to be called end time. I want to bring every other row within the start time column up by one index. So let's see how I can do that. I can use a calculate formula. And in my calculate formula, I'm going to use the max formula and apply it to my start time column. Now, applying it to my start time column, I will add another filter, and in my filter, I will be filtering this table to each of the index here. So every row will only filter to one row containing the index number in that row. So filter this table, table 1, where the index column equals to the index. However, we cannot write it like this because if I now close the bracket, it is only showing me the very last time, because I actually have to declare this portion of the formula as a separate variable outside. So I'm going to call it this row equals to index. So it will extract 0 as the value for the first row, 1 as the value of the second row, so on and so forth. And then I will return that exact same formula, but in this case, I will ask for it to filter to this row. Now it is giving me 10, 54, 55, 55. It is only corresponding to each row. I will need to add a +1 behind my index so that it will actually move up by 1 row. Okay, so 55 have now moved up, 7 have moved up, 11 p.m. has also moved up. But we notice here that there's a blank cell. In the previous case study video, we explored on how we can handle the error here. But let's revisit that again. But before that, let me change my table name so that's easier to see. So let's call this machine running time. Okay, coming back to my end time formula, I will use another variable called adjusted date time, which would be UTC now plus it by 8 hours, so as to reach GMT plus 8 or Malaysia time. This time will appear for any row that has the highest index number. So I need to write another formula for it to identify it as that. So the max index number, or rather just max index, would be the max of the index column. Hold on. Yep, the index column. And if the index of the current row equals to the max index, then let's have the adjusted date time, or else just run the previous written formula. Now, instead of giving me blank, it is giving me 10:44 because my system time is now 10:44 on the 4th of October. Once we have our start time and end time, we want to extract the start hour and the end hour. For that, let's call another new column, and let's begin with start hour. For the start hour, first, I'm going to extract the date for the start time. Okay, and then I'm going to plus it by a certain number of hour, being my start time hour. Zero minute, 0 second. That I would have gotten my start hour. So 10, 54, 22 would have a start hour of 10, and then 11, 32 seconds will have a start hour of 11. Now I realize that my machine running time is a bit of a long name, so let's just call it solution. Now let's extract our end hour using the exact same concept, which is first to call the date of your end time. And then plus it by the time, plus it by a duration using the time formula, and then extracting the number of hours by using the hour formula, applying it to end time column with 0 minute, 0 second. Now it is giving me my end time, end hour. So this would be 7 o'clock, 7 o'clock, 10 o'clock, 10 o'clock. Okay, once we have start hour and end hour column, we can now evaluate if any one of the row is a crossing hour row. So for instance, the beginning 6 rows or 5 rows are within the same hour, but every other row are within, are crossing hours. So it crosses from 10 o'clock to 11 o'clock, 11 o'clock all the way to 7 o'clock, 7 o'clock all the way to 10 o'clock. So we can simply identify if it is a crossing hour by using another new column called crossing hour equals to if the start hour does not equals to the end hour. Oops. We do that. Now, only those hours that are actually crossing hours will return true for this column. Now, let me change this end hour name because I forgot to add a space just now. Okay, now we are going to generate the hour interval duration using another table. See, in my trial file here, I actually generated it in a separate table. We'll do that here as well, but before we can segue into the separate table, I'm going to add 3 columns of time to use for calculation in my separate table later. The first one is just going to call duration minute. So this duration minute will calculate the most straightforward difference between the start time and the end time. So it's just going to take the end time minus it by the start time. Time minus by start time. However, I would like my return duration to be in minute instead of the current day. Hold on now. By default, it will return to me the difference in start time and end time in date format. I would rather have it in minute, so I'm going to enclose my formula in a bracket and then times it by 24 for 24 hours in a day and 60 for 60 minutes in an hour. Now it is returning to me minutes instead of days. Let's have it as 2 decimal place instead. And next, I'm going to add a new column. That is going to be the result between the next hour minus by the start time. So why the next hour? Take for instance now, if I have 10 o'clock as my initial, 10:50 as my initial start time. I also have let's try 7 o'clock in the maybe a simpler idea. 12 o'clock. 12 o'clock 57 seconds. So this is my end time. This is my start time. I want to know until the next hour, which in this case would be my 11 o'clock. In knowing the distance between 10:50 to 11 o'clock, I can know what is the running time for 10 p.m. Okay, so I'm just going to calculate this first gap to get the duration of running minute within the first or my start time hour. Then I'm going to generate another column again to get the gap between my end hour with my end time. So in this way, I will be able to get the running time within 12 p.m. So the first gap is to get the running time within 10 p.m. The second gap is to get the running time within 12 p.m. or rather 12 a.m. Okay, let's just get it in action first. So next hour minus it by my start time. So I will get the name of the column to be as straightforward as possible. First, I will need to generate my next hour. So next hour equals to my start hour plus it by a duration of 1 minute. Oh, sorry, 1 hour. Afterwards, I'm going to return a formula that would see me taking my next hour sorry, that will see me taking my next hour minus it by my start time. Then times it by 24, times it by 60 to get a million. Let's have it at 2 decimal place. Okay, now for my new column, I'm going to call it n time minus by n hour. So I don't need a separate variable here. I can just have it as a very straightforward formula. My n time minus by my n hour. Multiply by 24, multiply by 60. Now it is giving me all the different number. Okay, but this next hour minus start time and n time minus n hour will only be used if it is a crossing hour. So for the sake of readability, I'm going to make all of the rows that are false when it comes to crossing hour to have a blank result instead of a number result. Let's start with the n time minus n hour first. So if my crossing hour is true, then return, by all means return the current formula. If not, let's leave it blank. Let's do the same for our next hour minus start time. So if crossing, then this formula, or else just just type in the close bracket and it will give you blank for the false result. Okay, with that, we are ready to move on to our separate table. So going to my table 2 tab, I'm going to add a new table. First, I will generate the hour interval column. Let's call this hour interval table. Okay, so that's the table name. Now we'll begin with a generate series formula. So this generate series formula asks for three things: the start value, which in this case, I'm going to have it as the minimum of my start hour. Okay, then for my n value, which is the maximum value for the series that I'm going to generate, it will be my UTC now time, plus it by 8 hours for GMT plus 8. And then the increment value would be 1 hour. So beginning from the minimum value, it will keep increasing by 1 hour until it reaches the n value, which is UTC now plus time. Yeah, UTC. Okay, so for the 1 hour duration, it can just be time 100. Let's close bracket, and now we see that it will begin from 21st September 10 p.m. and kept going until my current system time 4th of October 10 p.m. But there is one more thing that I would like to change. That would be the name of my column. Rather than value, I would like it to be hour interval instead. For that, I need another formula called select column. So in my select columns, it first asks for a table, which in this case would be my generate series formula. Just to avoid confusion, let's have it as a variable. So I'm going to call this table, and then I will have it return. However, it seems like I cannot name my variable as table, as this is a reserved keyword for Power BI DAX formula. So let's call it series instead. Now, the first argument is series for my select columns, and then the name will be the name I would like to assign to my column. Let's call it hour interval, and the expression would be which column within my current series table would I like it to rename to hour interval. In this case, it will be my value column. So I'm just going to call that value from my series table. Press on enter, and now instead of value, it is displaying for me hour interval. Now let's talk about how we can calculate the duration for running status for each of the hour. Let's begin with the most straightforward duration first. For all of the cases where it is not a crossing hour, so it will be within the same hour. And we only want all of the status that are running. For the first start time, which is 10:54, 22 seconds to 10:55, 33 seconds, it will be 1 minute and 11 seconds. We want to also add up everything within 10 p.m. Okay, let's go back to my hour interval and start a new column first. I'm going to call this within same hour. We are going to write three separate columns. The first columns being the within same hour that we're writing now. Later, we'll be looking at how we can write for crossing hour, and another one is all of the hours that do not appear on the table. I will explain more as to what I meant by that. So within same hour. Within same hour, first we have to identify all of the cases where it is not a crossing hour. So let's call a filtered table. So I'm going to call let's call a variable or filter table. Okay. For the filter table, I'm going to filter my solution table with the filter expression being that the status is running and the crossing hour column are all false. Okay, so this would be the table that I want to evaluate inside my within same hour. But I want to evaluate it for each row, the specific hour interval. So for in this case it's 10 p.m. For that, I will have to call another variable first, which I will have to place on top of my filter table. Filter table variable. So this row will be my hour interval. So for each of the rows, it will keep running this row variable, which for this row will be 10 p.m., for the second row will be 11 p.m., so on and so forth. And the reason why I'm adding this is because I want my filtered table in this formula to also filter to the specific hour interval. So let me write it down first and then show you what's happening inside the solution table when I apply this formula. Okay, this row. Oops, sorry. I want the start hour to equal to this row. Now let's just write a return and let it return an error for now. Now, remember, we are applying three different filter. Status equals to running, crossing hour equals to false, start hour equals to this row. What's happening in the back end is, first it will, inside the solutions table, it will first filter to running, afterwards it will filter to false, then it will filter the start hour to only 10 p.m. In this case, we already have all of the 10 p.m.s. What I want to do now is to add up all of the duration minute here. Okay, let's now jump over to my hour interval and let's add up the duration minute. So in this case, I'm going to call it the calculate formula. And the calculate formula would apply the sum formula to my duration minute at the specific filter table that I have just created. It's called filtered table. Okay, now let's see. Let's have it return two decimal place instead of 0. So it's 2 minutes for 10 p.m. Let's see if that is the case in my solutions table. So for my solutions table, the duration minute is indeed if I add these three together, would be exactly 2 minutes. Okay, it seems like this has a little bit of discrepancy, so let me just quickly troubleshoot what's wrong with this one. I want the end time minus it by the start time, and then times 24 times 60. The decimal place would be 2. The data type, I would like it to be decimal number. Now it is returning correctly, accounting for the 11 seconds between my start time and my end time. I just had a little bit of a data type mismatch there. So now if I go over to my hour interval, instead of 2 minutes, it is returning for me 2 minutes and 18 seconds. So we solved the first question, which is for the within same hour. Right now, I also want to solve the problem for crossing hours. So I want to first apply the filter to all of the true cases, and then apply the filter to all of the running status, and then apply my start time, apply a filter to my start hour as well as my end hour. So let me show you what I meant later. Let's start by typing out the formula first. So let's call this crossing hour. And for the crossing hour, again, I'm going to call this row first. This row being the hour interval for each row. And in the hour interval, let's type out a return clause first, just for preparation. Again, I'm going to call a filtered table. But this time I'm going to call it crossing hour table. Maybe just call it a CH table. Equals to filter. So it will filter the solutions table to that of status being running. Then with the end condition, I will also filter the crossing hour to that of true, so I don't need to declare anything. I can just leave it like that. So this is a table filtered to crossing hour, and then the status is running. Now, I also need two other variables. The first one being the sum total for start hour minus, next hour minus by start time. I will use an underscore to denote the minus so as to not confuse with the rest of the formula. I also need another variable where it is about the end time minus by my end hour. Now let's let it return an error first and refresh ourselves on the solutions table. Remember earlier I generated these two columns. I want the sum total for both of these columns. Not necessarily the sum total, in that I want it in cases where the hour interval, in cases where inside my hour interval I have a 7 p.m. Let's see the 7 p.m. here. Yeah, for this row, I want it to return only the end time minus end hour. For the 11 a.m. row, I want it to return the next hour minus by the start hour. Because inside my solutions table, the 11 p.m. corresponds to only this, while the end hour, 7 p.m., corresponds to this one. Okay. Now let's jump over to our hour interval table and keep writing our formula. For the first one, I will apply a sum x formula instead. So for the a calculate formula would be more appropriate. Calculate, I want the sum of my next hour minus start time. Let me move this to a separate row. And the filter, I will apply my CH table. But it isn't enough for it to be my my CH table seems to be missing something. In that, I also need the time, actually the start hour to be, yeah, I have to further filter my CH table in this case. Filter my CH table or crossing hour table to that of where my start hour, the start hour of my solutions table equal to this row. Okay, now let's see what would return if I ask it to return the next hour of start time. Only one row has result, which is my 11 p.m. case. Why is it 11 p.m.? Let's jump over back to my solution. See here, my start time is 11 p.m. The next hour is 12 p.m. Now, it's not appearing on this table, but we know that this next hour is 12 p.m. And it would have run by 59 minutes and about 0.50 minute, which is your about 30 seconds something. So that would be my next hour minus start time, which is 59.47. It is now returning it correctly inside my hour interval. If I have this as 2 instead, it is 59.47. But my 7 p.m. is not returning yet. So for my end time, it is within the 7 p.m. interval. It should run for 55 minutes. The running time should compute to 55 minutes and 0.50 something for the duration of running time, which we already have it here. I just need to filter it inside my hour interval table. For that, let's write our end time underscore end hour variable. So in this case, it will be very similar to our previous formula, except I'm going to change the sum to that of n hour minus n time, the n time minus n hour. Okay, for the filter, it would be instead the n hour. Now let's have it return n time minus n hour. Now we see that it is only returning one row of result exactly at 7 p.m. The only thing that we need to do now is to plus both of these variables together. So the crossing hour running time, the running time within crossing hour, I will dedicate it as another variable. Crossing hour would be the total of next hour underscore start time plus it by n time underscore n hour. So let me return that crossing hour. Okay, now I have 59.47 as well as 55.55 for 7 p.m. and 11 p.m. However, I do not have any running time between 12 a.m. all the way until 7 p.m. But we know from my solutions table that for this row, it runs from 11 p.m. all the way until 7:55 p.m. of the next day, meaning that 12 a.m. for 22nd of September all the way until 7 p.m. 6 p.m. of 22nd of September, the machine kept running. So all of these rows should return for us 60 minutes. This we will write in the third new column, and then later we'll combine all three columns together in one column. So let's call this full running hour. And for my full running hour, I will again call this row equals to hour interval. And then we need to test whether or not the current hour, let's say 12 a.m., is an hour that's not appearing on my table, but they do fall within any rows Let me jump over to my solutions table. It do fall within any rows where, let's say if it's 12 a.m., 12 a.m. is larger than my start time and lesser than my end time. It has to be larger than my start time and lesser than my end time for any one of the rows where the status is running. So I'm going to write that in formula. Let's filter our table first. Filter the table to that of crossing hour, only crossing hour. Let's maybe start with status first, is running, and then the crossing hour is true. Oops, actually, yeah, the crossing hour has to be true. Then we can just close this off with double ampersand for the and condition. Okay, next we will evaluate if it is not available. Let's call it absent from table. To sum x apply it to the filter table, and then the expression would be if we want two conditions here, if and the start time, sorry, this row is larger than the start time, and this row is also lesser than the end time. Then return 1 or else return blank. Now let's have the formula return this absent from table first. You see here that it is not correctly identifying it yet. So let me see what's wrong. This row larger than solution start time, lesser than solution end time. Turn 1. Filter table, so the status equals to running, hour interval, crossing hour. Let's visit our trial file. Let's ignore the crossing hour filter. Oh yes, we cannot actually apply the crossing hour filter because this formula is supposed to run across every row. So now it is correctly identifying all of the hours. They are not appearing on my table, but I know that it's actually within my table. It's supposed to be lesser than or equal to. Lesser than the n hour instead. Lesser than the n hour. Okay, now it's only appearing up till 6 p.m. and it's not barging into 7 p.m. Instead of returning 1, I want it to return 60 minutes instead. So if absent from, oops, let's call it full running hour. If absent from table returns a number that's larger than 0, then return 60 or else return blank. And here we are going to call it full running hour. Okay, now it's returning us 60 minutes. Let's combine all three columns together. I'm going to first copy the formula over here, then add a new column. I'm going to call this running time. Paste that formula, remove the name. Let's have it return something first. Okay, so now it's returning for us 2.183 something. So it's exactly the same as the first column. Let's have the second column formula, copy it over to my running time. I'm going to dedicate some space here. Maybe remove this. Let's name this within a variable first. Within same hour equals this. Okay, then we dedicate a space for crossing out. I'm going to reduce the size of the formula so it's easier for us to see now. Again, remove the name of the previous column. Maybe bring everything together. Okay, and have it return crossing out. But we don't need a duplicate of this row because this row is always calling the same thing. So let me delete the other one. Now it is returning us the result for the crossing hour, which is over at this row as well as this one. Let's call in our full running hour formula inside our running time formula. We remove this return and again remove the name of the previous column as well as this row variable. Filter table, absent from table, full running hour. Let's see what it returns. Now, if I specify full running hour as the return, it is returning for us 60 minutes. Now it's just combining everything together. So the variable of running time, this hour running time, would be the sum of within same hour plus it by my crossing hour plus by my full running hour. Have it displayed as two decimal place. We see now that it has all of our previous formulas data. 2.18, 59.47, 55.55, as well as all of the 60 minutes. Every other hour that is not appearing on my table, so in this case would be clear off with this. Our last status here is stop. My hour interval table only one running status. So anytime between 7:55 to 11:19, between the 22nd of September to the 4th of October, they are not going to have any result. I can visualize it on my table now. Okay, pane switcher, let me switch it over to format. Visuals are up here now. I would like my x-axis to have my running time. Oh, sorry, my y-axis to have my running time. My hour interval to be over here. I want instead to just be hour interval. Okay, the visual changed a little bit here, so I'm not familiar with how to run it yet, but it would, the intent is for it to show us all of the hour intervals by the duration, which our data set already permit us to do that, so our visual should expect the same thing when we do it. Okay, that's all for this video. Do check out the timestamps for, sorry, the YouTube description for the timestamp, as well as the pinned comments for the formula used in this video. Bye bye.